We've looked previously at different number of events and outcomes. Let's take a look at the notion of probability. Probability is defined as the likelihood of an event occurring. Now, the calculation for probability is actually very easy. Simply take the number of outcomes of an event and divide by the total number of outcomes that you have. So, for example, we have 10 rolls on a dice. We have here heads, tails, heads, 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 tails, heads, tails, heads, tails. I have 6 heads and 4 tails. The total number of events is 10. So the probability of a heads occurring is 0.6 or 60%, where the probability of a tails occurring here is 0.4 or 40%. But all the combined probabilities for these events will add up to 1. Mathematically, these probabilities are represented as follows. The probability of any event equals the number of events divided by the total number of events. So for example, like we said, if the probability of a tail, we had the number of tails that we had divided by the total number of events. The notation here in the middle, 0 less than or equal to the probability of the event less than or equal to 1, basically means that the probabilities will range for 0 to 1 based on the event. It can never be below 0 and it will never be greater than 1. The notation here at the bottom is that all of the probabilities, each individual one, which is denoted as I, because I goes from 1 to n, where n is the number of different type of events that you have, say heads or tails, that would be 2. So it'd be the probability of the heads and the probability of tails. When you add all the probabilities together, you will get 1. This brings us to the notion of a relative frequency. If there are 2 outcomes, such as a head or a tail, the probability of each event occurring is known if they are equally likely to occur. So this would be 1/2 or 0.5, which is standard for a coin. When the frequency of the outcomes are not known and the likelihood of outcomes are different, we can still assess a probability. Let's take a look at the example. Consider a given outcome of traffic accidents on a given day of the week at any given intersection. The relative frequencies can be shown on the table on the right. We literally would count the number of accidents that occurred, say, on a Monday, Tuesday, Wednesday, and so forth. On Monday, there were 3 accidents. On Tuesday, there were 4 accidents, and so forth. We add them all together and we get 25. So the relative frequency of the number of accidents on a Monday is 3 divided by 25, or 0.12. The relative frequency of accidents on a Tuesday is 4 over 25, which is 0.16. And you can see if we add all of these together, we will get 1 when we add all these relative frequencies. We have the concept of a subjective probability because occasionally data is not available. We don't have something that's marked off. But we can use an acceptable gauge for a probability and use some general knowledge or experience to assess the probability of an outcome. For example, a project manager assesses that a given project has a 70% chance of being on time. We could therefore assess that the probability of E, that is, that the probability of being on time, is 0.70, meaning that the probability of it not being on time is 0.30, since the probabilities must add to 1. And as long as these probabilities add to 1, the probability space is valid. But be cautious when using subjective probabilities because they tend to include personal biases.